So I was suddenly interested in math for no reason at all, especially in the unsolvable math problems, because when you hear of math, you immediately think of big numbers to solve one stuff, right? So are there any weird math problems that no one has solved? So I looked into it on Reddit, and that's where I found about Collatz Conjecture. It's that veritation video with a thumbnail of 3x plus 1. I did not watch it because god damn, 22 minutes is too long for this brain rot. So I looked it up on Wikipedia, like a normal person would do. And holy shit, this is a lot. So, time to learn, I guess? Lothar Collatz, the man behind this mess of a game, introduced this idea back in 1937. 2 years after getting his doctorate, he decided to terrorize the math community for decades to come. Okay, now let's start with what even the fuck is this? This behemoth of a problem is literally just a game. This God knows 50 billion words article is literally just for a mathematics game. So here's the rules of the game. First, you take a number. Must be a positive. Then if your number is even, you divide it by 2. Else if it's odd, you multiply it by 3 and then add 1. Hence 3x plus 1. Here's an example. Let's use the number 12. Since it's an even, we divide it by 2 and get 6. Even again, so we get 3. Now 3 is an odd number, so we multiply it by 3, which is 9, and then add 1, which is 10. We're back to even. Then we get 5. Now an odd. Then we get 16. And then 8. Then 4. Then 2. And then lastly, 1. Okay, cool, but what's the problem here? The question that mathematicians lose their mind over is, can you always get to number 1, no matter which number you start with? Many mathematicians has labeled this conjecture as this shit hard and what even the fuck is this? So yeah, that's that. There's also a thing called stopping time and total stopping time. Stopping time is when the chosen number becomes smaller, so basically the steps to get to 1, and the total stopping time is when the number finally becomes 1. Now, there's some numbers that have longer stopping times, obviously, like for example, x equals 27 would take longer to reach than x equals 19. You might expect that the sequence will decrease steadily each step or maybe increase for a few numbers and then decrease again. But that's not always the case because again, for example, x equals 27 reaches up to 9,232 before continuing its path to 1. There's also a special case for numbers that's a power of 2, so 2, 4, 8, 16, 32 and so on, where the sequence just goes straight to the point since you just divide it. Here are some cool pictures before we get into more brain fuckery. This is a tree-ish graph for the first 1,000 numbers on their way to 1. You can see that 871 has more steps to take before getting to 1. So it's not just the bigger the number, the more the steps. Here are some more pictures. Done? Alright. Get ready because I'm going to shoot so much shit in your brain for the next few, seconds, minutes, I don't know. Just know that these are the arguments on why the answer to this question should be yes. As of 2020, people have tested the Collatz problem using computers and went as far as 2 to the 68th power is about 2.95 times 10 to the 20th power. That's obviously a huge fucking number, but there are infinite positive numbers, so this is really not a good evidence that all numbers will eventually lead to 1, especially since all does not really exist when talking about numbers. Here's another one. Try to look at the sequence where if you only consider the odd numbers, then each number would be on average 3/4 of the previous one. So theoretically, each odd number in the sequence should become smaller over time, which should eventually lead to 1. But again, not a good proof since just because we've seen it decrease multiple times doesn't mean that it will always be that way. Many more mathematicians have argued that since most of the numbers go down a lot even if they started high, that must mean that all sequences will eventually lead to 1. Which makes sense, right? Like, if you have seen 5 billion times of the same thing happening again and again, you would think that, well, that shit will always be like that. But you can prove that since there's no end in it. It's like saying the chances of God striking you down from above for learning this shit is low, but never 0. The chances of it not getting a 1 could either be really low or 0. Now, moving on to cycles. But what is a cycle? It's a loop in the sequence of numbers where you just repeat the same number over and over. So far, the only known cycle is the loop of 1, 2, where 1 goes to 2, then 2 goes back to 1 and repeats. If there's a chance that there are any other cycles besides the 1, 2, then it must be at least 186,265,759,595 steps long. But if it's proven that all numbers less than 3 times 2 to the power of 69 in the sequence reach 1, then it would be at least 355,504,839,929 steps. As a matter of fact, a mathematician discovered a rule that any other cycles must follow. P equals 301,994A plus 17,087,915B plus 85,137,581C, where B should be greater than or equal to 1 and both A and C should be equal to 0. Another type of cycle or a loop is called K-cycles, where the cycle can be split into sections, where in each of these sections the numbers go up when odd and down if even. So far, the only cycle we currently have is called the 1 cycle, which is, you guess it, the 1-2 cycle. Mathematicians have looked for other types of cycles up to k equals 91 and have not found any. There's also another way or another approach to prove that every number eventually leads to 1, where instead of proving all numbers lead to 1, we go backwards, where we try to prove that 1 leads back to all numbers. So instead of dividing the number by 2 when even, we multiply it by 2, and instead of multiplying it by 3 then adding 1 afterwards, you subtract 1 first and then divide it by 3. Let's put that to test. Let's take a number. Let's say 10. Since it's even, we multiply it by 2 and we get 20. This means that 10 could have come from 20 in a previous step of the original, which is true. But what if let's say we use 9? Since it's odd, we subtract 1 from it and divide it by 3, which is around 2.67. However, 2.67 isn't really a number. I mean, it is, but it's not a whole number, it's a decimal. So that means 9 can't be a starting point for any sequence since it only works with whole numbers. That's the cycle part. Now let's talk about parity. Parity sequence is basically the tracking or the logbook of the sequence. So like for example, x equals to 5. If we apply the rules, we get 16 to 8 to 4 to 2 then finally 1. Pretty simple. So, what parity is, in each sequence or steps, you check if the number is an even or odd. So starting with 5, we get 1, and then 0, 0 again, another 0, 0, and 1. That's the parity sequence of x equals 5. Now here's a fun game. What do you think is the parity sequence of God during the building of the Tower of Babel? Why didn't God just strike it down while it's still low and just give them a warning? Doesn't God know what we're all thinking? Do you think it's because He wants them to have the hopes that we can actually achieve our goal and then destroy it at the last minute? I'm sorry, I'm getting off track here. Let's move on. For a while now, we've all been talking about positive numbers, but what if we include 0 and the negatives? Then it would be a totally different thing, since by including the negatives, we are not just dealing with infinite positives but also infinite negatives. So instead of just one cycle that we would have a total of 4 cycles. Well, actually 5 including 0 to 0, but we'll exclude that for the sake of the numbers with actual value or something. So for the loops, what we got are 1 to 4 to 2 to 1. That's the first loop. Then we have negative 1 to negative 2 to negative 1. Then negative 5 to negative 14 to negative 7 to negative 20 to negative 10 to negative 5. That's also another one. And negative 17 to negative 50 to negative 25 to negative 74 to blah 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 blah. Here's the rest. I ain't reading all that. You know what? No. What I'll read is the actual reason why God struck down the tower. I thought for a long time it's because God doesn't want the humans to reach Him, but no. Well, yes and no. Because humans can't actually reach God, but the actual reason is that the humans or the people building it are getting too powerful. And mind you, this event took place around 600 BCE. How about now? With all this technology and stuff, we're more powerful than ever. Even this thing I thought we should be considered a blasphemy to God. With all these formulas and infinite numbers and these ones and zeros and... oh shit. Zeros and ones. Ones and zeros. The binary code. The universal language of what? The computers. If God Himself strikes down humans for getting too powerful just for building a stupid ass building, how about computers? Those fuckers can process what humans can't. Can build more than humans can't. This script is even written through a computer. You're watching this video through some kind of computer. The end is near. God soon will strike us down for the what? Second? Third time? I don't know, but what matters is that the end is soon. The end is nigh. The computers will doom us all.
Here we go again. So they're finally back. It's been a long time. They're bringing you a brand new rhyme. You love them all in DK6 Foul, and I bet you're wondering, where are they now?